Good morning everyone. So today we will start with coefficient of friction. So coefficient of friction is the ratio between limiting friction to normal reaction, which is denoted as mu. So as per the notation, mu is equal to F by N, where F is the friction force and N is the normal reaction. So as we know that from the angle of friction, the ratio of friction to normal reaction is equal to tan theta. And now as per the coefficient of friction, mu is equal to friction to normal reaction. Hence, it is proved that mu is equal to tan theta. That means the coefficient of friction is equal to angle of friction. Now we have to prove the angle of friction is equal to angle of repose. That means we have to determine the relationship between angle of friction and angle of repose. So here you can see this diagram. This is the object which is lying on a inclined plane, which make an angle phi with the ground surface. This is the W cos phi, and in the downward direction the weight of the body is acting, and the left side of the body here W sin phi is here, and on the opposite to the weight normal reaction is acting, and here is the friction. So let W be the weight of the body which is on the point of sliding down an inclined plane of inclination with the horizontal, and this phi is the angle of repose for the body which is here. Now resolve the part of W along the direction perpendicular to the inclined plane, that is this one, which is W cos phi, and while resolving this W along the horizontally, we have W sin phi. Now assume that the F is equal to limiting friction, which is in this direction, and R is the normal reaction, which is here. So according to the equilibrium equation of the body on the inclined plane, we have the algebraic sum of the resolved parts for forces along the inclined plane is equal to 0. And next one is the algebraic sum of the resolved part of the forces along a direction perpendicular to the inclined plane. That means the summation of vertical forces is equal to 0 and the summation of horizontal forces is equal to 0. So, according to the horizontal forces, here we have to consider the right side forces and the upside forces, that is R and F, both are in positive direction, and the forces which is acting left side of the body and downward to the body, those forces are considered as the negative forces. So while applying the equilibrium equation along the horizontal portion, we have friction force minus W sin phi is equal to 0. That is equal to F is equal to W sin phi. And we know that F is equal to mu r, because we know that the coefficient of friction is equal to the ratio between friction to the normal reaction. Hence, F is equal to coefficient of friction into normal reaction. So that's why this F is replaced by mu r. So that is equal to W sin phi. So we will consider this as equation 1. Similarly, by considering vertical forces in equilibrium condition, we have R minus W cos phi is equal to 0, because R is acting on the upward side and W cos phi is acting at the downward side. So R is positive and W cos phi is negative. So R minus W cos phi is equal to 0. Hence, R is equal to W cos phi. So we will consider this equation as equation number 2. Now, we have to substitute the value of R from equation 2 in equation 1. So, we have to put the value of R from the equation 2. That means, here we have the R is equal to W cos phi, and we have to replace this R value in equation number 1. So, we have to put here the value of R as W cos phi. So, by putting the value of R in equation 1, we have mu W cos phi is equal to W sin phi. That is equal to mu is equal to W sin phi divided by W cos phi. So here W and W is cut out. So that is sin phi by cos phi. So we know that sin by cos is tan phi. And according to the relationship between coefficient of friction and angle of friction, we know that mu is equal to tan theta. So we can put in the place of mu tan theta. So that is equal to tan theta is equal to tan phi. So here tan is cut out. That is equal to theta is equal to phi. So now it is proved that, as we know, theta is the angle of friction and phi be the angle of repose. So we can say that the angle of friction is equal to angle of friction. So here angle of friction is equal to angle of repose. So this is all about the relationship between angle of friction and angle of repose. So today this much. We will continue from this in the next class. Thank you.